Alright guys, in this video I am going to discuss about binary search tree. As you know that binary search tree has only two unique child. If you want to make a duplicate child, then you have to do some other twist in the code, right? Okay, at this time let's do unique two child in binary search tree. Okay, let's start coding. So first, as usual, let's start creating element. We are going to put the in type element and then the tree node, which is left, as we used to do in linked list, predecessor and successor, left and right. At this time, they both are null. Let's create the tree node constructor. So inside that, let's make a space to receive the element, the input. This element, which is up there, that belongs to the object, equals from the input, okay? This way, we have now our tree node is ready. Let's go to binary source tree, which is the real tree now. Let's create one static tree node. Let's make it root at this time, which is still null. Okay, this I'm going to explain at last. I'm just following exactly what we used to do in linked list, okay? So that is going to be easy for you to understand, simple to complex way, okay? So method would return the tree type. So it's going to be insert, and inside insert, what we are going to insert? The node itself, okay, node, and then the element, okay, the element that we are going to put inside the tree. If this node equals null, then do what? Then node equals new tree node, okay, and inside that node we are going to pass this element which is coming from the input. Now then after, what we do? Return that node. This rate is gonna go soon, or maybe if you do not want to say it, I'll do it now. Okay. Now then after, now we are going to insert into the tree. Okay. The first element is already inserted in this case. If it is null. Now if it is not null, then if this element, the element that we are going to put into, is less than the element which is in the tree, that means the node dot element. In that case, you have to call node dot left side. Then after that means go to left side of the node, then insert the same, okay, the same method. All right, and then node dot left, then after element. If that is not the case, if the element is bigger than the element in the tree node, then do this. Node dot right equals, go to right side, then after get ready for insert, then insert what? Node dot right one, then element. Now this insert method is ready. Okay, then after, let's try to make a method that prints the tree. Void print, let's say BST in order. Okay. In order means that is going to the order. What we are going to print? The tree itself. So you have to pass it, okay? So which tree? Tree node, okay, node itself. And then if this tree node is empty, if the node equals null, then do what? Return it. Job is done. And if not, do what? Else you have to call the print BST in order. Go to left side of the node. Print that node dot element. Go to left side of the node and print that one, then print BST in order, then print what? The right of the node. Now let's call it, okay? Public static void main. We have made one root here, right? The main root is there. We are going to create only binary search tree, new binary search tree. We are going to connect to this root, okay? This is the main root. Root BST dot insert. What we are going to put? The same root. This root is going to connect to this one, and then it gets initiated. Put, let's say 100. Let's do this much for now. Run it. Then after, we have print method here. Call print method. Okay, let me do one thing so that I can see in one line. BST dot print in order. The root is passed. Which root is passed? This root is passed. Okay. That comes from where? That comes from there. Okay. This comes from here. This is the main tree, and inside that tree, this root has been passed. This root has a connection to all root because of this method. 20, 45, 80, 90, 100, 110, and 20. It is sorting into ascending order. This is the basic structure of binary tree. Thank you.